Welcome to 6.1, Graphing Square Root and Cubic Functions. We're going to graph and find the inverses for both. So let's go ahead and get started with our square root parent function. So I'm going to quickly sketch our points of interest. Now remember, we can easily find the square root of 0 to be 0, square root of 1 to be 1, square root of 4 to be 2, and square root of 9 to be 3. Now, these are the 4 points that are expected to be seen for square roots if they fit on your coordinate grid. I'm going to go ahead and connect the dots. And what's going to be really important for us is that we remember the pattern. We're going to have a point at the origin, 1, 1, 4, 2, 9, 3. And I hope it's going to kind of refresh your brain on what we did with graphing in Unit 1. The domain, my x values start at 0. They keep going to infinity. My range, the y values, start at 0, keep growing, and they will increasingly grow to positive infinity. And there's going to be brackets for both because there is this point here, meaning it's included in our data. Now, for number 2, I do have some transformations that have been applied. I have shifted everything to the right 4, which has shifted my y-axis from 0 to 4. And remember, anything inside is a left-right shift, and we always do the opposite of what it looks like. Now, +2 is an up-down shift, and since it's positive, we're going to go up 2. This is going to fall in line with exactly what it looks like. So I shifted my x-axis from 0 to +2. Now, the reason why I like to draw these lines is because this is going to indicate my new origin. I'm no longer going to be graphing from 0, 0. I'm going to be graphing from 4, 2. So I'm going to take all of these points that fit and place them on my graph. So I have my points 0, 0, 1, 1, 4, 2. Now, 9, 3 isn't going to fit, so I'm not going to sketch it for this graph, but I am going to connect my dots. And I'm going to get my graph of, hopefully it shows up, there we go, my square root function. Now, the domain, my x values are going to start at my new y-axis at 4, and my range is going to start at my new x-axis 2. And again, I will have a bracket because they are included in the domain and range. Now, 3 gets a little bit tricky because I do introduce some different types of transformations. Now, I am going to see a negative in front, which indicates a reflection over the x-axis. The 2 is going to be a vertical stretch of 2. I don't have any left-right shifts, but I do have a shift down 3. So I've shifted my x-axis from 0 down to -3, and I went ahead and drew my y-axis in its original position of 0. Now, the tricky thing here is my graph has changed. It's not going to look exactly as it does in the parent function. It's going to look slightly different. This reflection over the x-axis is going to cause it to go downward, to decrease. And this vertical stretch is going to multiply all of the y values from my parent function by 2. So I'm going to go ahead and show you my dots, and then I'm going to explain them as we go through the 4. So 0, 0 is not going to change. It's always going to be on the origin because we cannot reflect it, and 0 times 2 is just 0. Now, our parent function point 1, 1, if I were to reflect it over the x-axis, it's now going downward, and if I were to multiply it by 2, it's going down 2. So I went right 1, down 2. Now for my point 4, 2, I went 4, -4, and then for my point 9, 3, I went 9, -6. So now I have my curve, and my domain is going to be from 0 to infinity, and my range is going to be from -infinity all the way up to -3. Now let's review inverses. So something you might recall when we're working with inverses of a square root function is we have to identify domain restrictions. So anytime we start with a square root in our original function, there is a domain restriction that needs to be identified. So don't forget that. So first thing you're going to want to do is you're going to want to rewrite it so that it's in terms of x and y. you're going to want to switch your x and y values, and you're going to want to solve for y. So for my problem number 4, the first thing I want to do is I want to add 1 to both sides. I'm going to want to cancel out the square root, so I'm going to take the squared of both sides of the function. Remember, whatever you do to one side, you have to do to the other. And my last step to get y by itself is to add 2 to both sides. Now, for proper function notation, we are going to want to rewrite y so that it is f inverse of x. Now, again, anytime I start with square root, I have a domain restriction. My answer is almost complete, but not quite. Remember that an inverse, we have domain and range switch. So I'm going to look at my original graph, my original function, and I'm going to quickly sketch it. So this has been shifted to the right 2, down 1. Doesn't have to be perfect, doesn't have to be pretty. But when I see this graph, I notice my domain is going to be from 2 to infinity. My range is going to be from -1 to infinity. Now, domain and range switch. So if I want the domain restriction of my inverse, I need to be looking at the range of my original. So going to include in a statement that says the domain is from -1 to infinity for the inverse function. Now, when I'm starting with a squared, it's not as tricky. I am going to go through the same process. I'm going to rewrite f of x as y. I'm going to switch x and y, and I do want to solve to get y by itself. So I'm going to subtract 1, going to divide by -2, got a little ahead of myself, and I'm going to take the square root of both sides. Now, the important thing to remember here, because our square roots tend to be tricky, this relationship is a very tricky one. When you are solving and you are creating your inverse equation, you have to include plus or minus. If you do not have plus or minus, it is not correct because I'm starting with a parabola. I don't just want a singular square root piece. So going to keep solving, going to add 3 to both sides. Now, of course, you could put the plus 3 on the right-hand side. That is absolutely okay. It's the same answer, but I just went ahead and wrote it in front, and I changed it to inverse notation. And notice again, I do have that plus or minus. For number 6, we are going to create a square root function that would have a domain of -4 to infinity and a range of -infinity to 7. So one thing I do want to note here is that these two values, -4 for domain and 7 for range, are going to act as our new x-axis and our new y-axis, because this is going to be the intersection point of our new origin. So I went ahead and sketched a coordinate grid with these two values on it, and I'm going to draw my center point, my origin point, the first point I usually draw for all graphs, where they intersect. Now notice I did draw my curve going downward. The reason why I did that was because my range includes -infinity. So I can't have it going in the normal upward direction, because if I did, it would be a range of 7 to +infinity. So now that I have my graph somewhat sketched out, I'm going to go ahead and write an equation for it. So I have y equals, because anytime you're writing an equation, it should say y equals. Negative is going to account for this reflection over the x-axis. Square root, because it's a square root function. X plus 4 is shifting to the left 4, and plus 7 on the outside is shifted up 7. So a function that would have this domain and this range is given here. Now you could be a little fancy and apply a vertical stretch or vertical compression, and that would still be a correct answer. Okay, number 7. The x-intercept of the square root parent function is 0, 0. Without using transformations, how would you find the x-intercept of g of x equals square root of x minus 8? Well, this one's pretty easy because the x-intercept is where y equals 0. So I went ahead and replaced my g of x equals with 0 equals. And I'm going to solve by squaring both sides, giving me 0 equals x minus 8. So 8 is equal to x. Therefore, the x-intercept is 8, 0. Number 8, the graph of f of x equals square root of x minus 3 plus 4 is given. Using the graph, make a conjecture, so make a conclusion about the solution to the equation square root of x minus 3 plus 4 equals 0. Well, anytime you are finding a solution, we always like to treat the left-hand side as one equation and the right-hand side as another. So if I were to turn this 0 into an equation, that would be y equals 0. And anytime I have two graphs, the solution is always going to be their intersection. Well, these two graphs are never going to intersect. So I can say no intersection is going to indicate that this would have no solution. Now let's graph some cube root functions. So we're going to start with the cube root parent function. I'm going to show my key points. Cube root of negative 8 is negative 2. Cube root of negative 1 is negative 1. Cube root of 0 is 0. Cube root of 1 is 1. Cube root of 8 is 2. Once I connect my dots, I can see my swimmer. Remember, one arm above water, one arm below. And the domain and range for the cube root parent function is negative infinity to positive infinity for both. Now we're going to look at number 10. I do have some transformations. I have been moved to the left 4 and down 5. My origin is no longer at 0, 0. Now it's at negative 4, negative 5. So I'm going to sketch my points from this new origin following the pattern. Remember 1, 1, negative 1, negative 1, 1, 1, negative 1, negative 1. The only point that does not fit on my coordinate grid is this point, negative 8, negative 2, which is okay. So I'm going to connect my dots. And again, my domain is going to be negative infinity to positive infinity, as is my range. Now, for number 11, I do have a couple more transformations. I have been reflected across the x-axis. I have a vertical stretch of 3, and I've been moved up 3. So my y-axis is going to remain the same. However, my new x-axis has been moved up 3. Now, I'm going to reveal my points first, and then I'll kind of explain how I got them where they are. So normally, again, 0, 0 is just going to be at the origin. Nothing special ever happens to that, but I do have the point 1, 1. Now, a reflection across the x-axis is going to cause this point to go down instead of up, and we're going to multiply it by 3. So now I'm not just going to go right 1, up 1. I'm going to go right 1, down 3. And then same thing on the other side. I'm going to go left 1, up 3, because normally I would be going down. And then I'm going to come out 8 units, and instead of going down 2, I'm now going down 6. Same thing on the other side. I'm going out 8 units, up 6. And I'm going to connect my dots. And again, domain and range are both negative infinity to positive infinity. The last thing we're going to cover is inverses of a cube root function, and you do not have to worry about domain restrictions for these for cubics and cube roots because they're always going to have a domain and range of negative infinity to positive infinity, so we're never going to have a domain restriction. First thing I'm going to do is change this to y, going to switch x and y, and I'm going to solve for y. So I first subtract 6, divide by 2, and then I'm going to take the the cubic of both sides. And then I'm going to subtract 5 and rewrite it as f inverse of x. For number 13, going to change f of x to y, switch x and y, add 8 to both sides, take the cube root of both sides, and then I'm going to change y to be f inverse of x.